So we are looking at the transformations homework, and there are 20 problems there. We won't do them all, but I want to get a sampling of them so that you know kind of what to do when you get there. Some of these may be parameterized, right? So that you may have a different function here depending on how the parameters are set. But I'm not sure. It's be kind of hard to draw the distractors for the graph. So this may be sort of a fixed one, right? So I'm going to say this is a shift of, well, let's do it in GeoGebra. Okay. So are we looking at GeoGebra? Let me go to speaker view here and change that. So I'm looking at, and so this was from some other problem I was working on. Let me get the proper window, if I can find it. There it is. And I want to choose the choosing button and delete these guys and put in 1 over x. That's our base function type. And what does the graph of that look like? Well, let's zoom out a little bit, right, so you can see better. The reciprocal function, right? So if the input is 1, let's zoom in a little bit here. So we can see if the input is 1, then the output is the reciprocal of 1, which is also 1, right? So that would be a point right about here. Should we plot a few points? 1, comma, f of 1. That's a point there, right? And here's 2, comma, f of 2. That's a point there, right? So the reciprocal of 2 is 1/2. And if we had 1/2 as the input, what would the output be? Oh, it'd be a 2, right? The reciprocal of 1/2 is 2. All right, so there's 3, 2, and this is going to have odd symmetry. That is symmetry through the origin. All right, so the reflection through the origin of this point B is going to be, whoops, I want to draw -2, comma, f of -2, right? And so I can actually draw the line segment, sort of think of this geometrically. There's that transformation, which is a combination of 2 reflections, right? You got a reflection in the y-axis and a reflection in the x-axis. And that combination of those gives us what's called a reflection through the origin. So a reflection through a point, right? Okay, so we want, should we maybe turn that segment off? We can turn it off. We don't have to see that. We want to form a transformation, right? So for our function, we have f of x minus 1, right? So that's a horizontal shift to the right. Does that look like a horizontal shift to the right? Well, let's see. Okay, so this is a new function. And what happens to the point D? Well, it's going to shift 1.1 to the right, yeah? So we're going to have then, I guess, -1, comma, h of -1. Oh. For some reason, it didn't like that. I'm not sure why. Should we try that again? I don't see it at all. I've got 4 points. Yeah, I don't know what happened to that. Okay, so I'm going to enter in -1, comma, maybe I had a period or something that just didn't compute. H of, and it is h, right? The name of the function is h. There it is. All right, so so the point D is shifted 1 unit to the right. That's a horizontal line segment, right? Where's the point C go? Well, C is the output on F if the input is 1/2. So if I add 1 to 1/2, I get 3/2, right? And then, is that a comma, h of 3/2 is right there, right? So that's also a horizontal shift. If I draw the line segment connecting these, you see that's a horizontal line, right? So C goes to F through the transformation. But we're not done, right? We have another transformation. Should we also see what happens to A, the point A? Well, that's originally at 1, and then we're going to say it's going to 2, which is there, right? And that's also a shift of 1 to the right. So these two segments have the same length. They're both of length 1, right? This segment J and the segment K there. I don't know, can I? Oh, I'm looking at the wrong thing. How about B? What's going to happen to B? Well, that's going to go to 3, comma, H of 3. That's input and output, that pair of points. And I can also draw this segment here. All right, so those are all 1 unit to the right. I mean, it creates a sort of optical illusion, right? Because, you know, Y is also changing, and these curves appear to be getting closer together. And yes, vertically, they're getting closer together, but horizontally, they're always 1 unit apart. So the red curve is exactly a shift of 1 unit to the right of the green curve. All right. So then we also have in our function here, we see this function, right? That's got a shift up of 2, right? We replace y by y minus 2 and then add 2 to both sides of the equation to solve for y. And that gives us a shift up of 2. So I want to do that. So I could either add 2 to h of x, or I could, you know, say f of x minus 1 plus 2. Shall we do that? So here is f of x minus 1 plus 2. Does that look right? Oh, I don't want that point. Oh, what happened to my function? Oh, I guess I didn't give it a chance to take, huh? So f of x minus 1 plus 2. Okay. So then all the points, so that's a combination of a horizontal shift by 1 and a vertical shift by 2. Right, see, so this curve here is the red curve shifted up 2. Is that clear? Maybe not. So let's say, okay, I've got this point on the red curve, which is at -1. What point is that on the, I guess it's a black curve now, that's P of X. Oh, I'm sorry, you're not looking at what I'm looking at. Let's go to GeoGebra. There, you see what I did? I entered in f of x minus 1 plus 2, and it called that new function P of x, and that's what we're looking at here, right? So maybe we should zoom out a bit, right? And take a look at what have we got. We've got, there's a vertical asymptote, and let's take a look. What happens to this point E? Well, the original function 1 over x was at this point D, then we shifted that 1 unit to the right, we got to the point E, and now we want to shift up 2 units, which is on the function P. So I'm going to say, give me -1, comma, P of negative, is that P? P of -1. Huh, it's not doing it. I'm not sure why. It's got, oh, I got an extra parenthesis for some reason. Okay, so that's a vertical shift, and you know, if we could draw the line segment connecting, oh, I keep forgetting which window is the real window. Yeah, so that's it. So there are the 2 shifts, right? So the green curve is the 1 over x curve, that's f of x, The red curve is f of x minus 1. That's a shift of 1 to the right. And the black curve here is f of x minus 1, the x minus 1 on the input, right? And then plus 2 on the output. So the output is shifted up 2. And you see that all these vertical, if I were connected, say this y-intercept here. Oh God, I don't know which curve I'm looking at. With this y-intercept here, that's also a shift of 1, right? How about this point F? Well, that's where x is 3/2. So if I say, give me the point 3/2 comma p of 3/2, there it is, right? That's a shift up 1, and right, that's what. So that's a two-step journey, right? One shift to the one right, shift right 1 unit, and then shift up 2 units. And so what characterizes this? Well, let's turn off this guy, and all these line segments are just distracting me now. So turn them all off. Oh, how about these points? Turn off those points too. And let's look at some of the essential components. So this is the transform function. This is p of x, right? And this is the graph we want to look for. But we're looking for actually for two things, right? So the original graph, f, has a vertical asymptote along the y-axis and a horizontal asymptote. Do we know about asymptotes? Yeah, maybe a little bit. So to be asymptotic means to approach, but never actually hit. So you get arbitrarily close if we, whoops, I don't want that point. Oh, what happened there? Okay. So I want to look at the original function here, right? Okay. So as I go up, you see that the x values are getting arbitrarily close to the y-axis, but never actually hitting on it, never intersecting. That's asymptotic behavior, right? Same thing down here, approaching from the other side, right? And also horizontally, right? Horizontally, as I go out here, the y values get very close to the x-axis, but never actually intersect it, right? And if you think about it, it kind of makes sense. Look at the formula, right? If the input is 0, the output is undefined, right? So there is no y-intercept. Similarly, there is no input that'll give you an output of 0. I can make it as close to 0, the output as close to 0 as you like by taking x large enough, like the reciprocal of 1,000,000. That's 1,000,000th. That's close to 0, but never hits on it, right? So it's got a vertical asymptote on the y-axis and a horizontal asymptote on the x-axis. So now if I look at this transformation function, its vertical asymptote is shifted over 1 unit, right? So if I write the line, the vertical line, x equals 1, that's the vertical asymptote, right? So it has also shifted over by 1. And the horizontal asymptote, that's shifted up by 2, right? So I'm looking for a function over here which has those properties, right? A vertical asymptote on 1 and a horizontal, that's this one, right? Should we submit? Resistance is futile. Yeah, it likes that one. Questions about that? I need to have the chat going here. And oh, Brianna, okay. Allow me to count you as here, which means going to here, Contreras. And from the homework 1, yeah, there's a question about homework 1. Yeah, let's, oh, and Tia is here. Gotcha. Yeah, we can do that. That's easy. So the request is to look at homework 1 the last problem there. So number 14. And can we get rid of that? Yeah. So it says, complete the description for the piecewise. Oh, well, I'm in the way now, aren't I? Function graph below. Use interval notation to indicate the intervals. Okay. So there should be one big curly brace here. I guess they didn't know how to make one big curly brace, so they made 3 little curly braces. So I'll tell you what, let's switch over to pencil and paper. And I will sketch this graph, reproduce the graph here. So we're going from -6 to 6 and -7 to 7, horizontally, vertically, not necessarily in that order. Okay. So here's my y-axis, and here's my x-axis. And I think I'll say 1, 2, 3, 4, 5, 6, 7. Sure. 1, 2, 3. These are perfectly evenly spaced hash marks. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6 down, right? And the graph shows from -5 to -1, the output is -4. So that's going to look like this, where the dots are filled in if the function is defined to be at that point. Then we have a jump. At -1, we disappear and reappear at where y equals 3. But in fact, the function value at -1 is the filled in dot, which is -4. And so we maintain a constant output of +3 from -1 up to 2, including 2, but not -1, right? So I'll make a filled in dot there and draw this segment here, right? And then we have drop down to -1 and out to 4. Like so. And so how would you define this function piecewise? Well, we'd say f of x, the formula for the output, which is in each case is just a constant, right? But it depends on where the input is. So usually you make just one curly brace like this. And so the rule is if the input is between -7 and -1, then the output is -4, sorry. -4, and that's if x is an element of the interval, and this is from -5 to -1, including the endpoints, right? So that's kind of crucial that you have the square brackets. And this symbol here means element of, right? So your element of this interval, this is interval notation, right? The left endpoint is the first entry, comma, the right endpoint is the second entry. And then whether or not the endpoints are included as part of the interval is denoted by either square brackets if they're included or rounded parentheses if they're not. So for instance, from -1 up to and including 2, the output is 3. And so that's if x is in the interval from not including -1, but including 2. So that's what's called a half open interval. An open interval does not include its endpoints. A closed interval does include its endpoints. And so this is half open, half closed, I guess. It's a jar. Well, that's what you say when a door is not quite completely closed. We don't use that term in math. Okay, and then the output is -1 if we're between 2 and 4, not including 2, but including 4. So from 2 up to 4 and including 4. And that's it, right? There's no other input that's allowed. So the domain of this function is the interval from -5 up to +4, including -5 and -4 and all points in between. You see that it would be a mistake to have like a filled in dot here, because then it wouldn't be a single valued function, which is sort of redundant. If it's a function, it has to be single valued, meaning that for each input, there's only one output. So if we were to fill in this dot, then it wouldn't be clear what the output is for -1. Is it -5 or is it +3, right? So that's why, you know, it's either filled in here or filled in there, but not both. It could be neither, in which case it's not, doesn't have a function value. Okay, so when we go back to the problems here, yeah, what do you fill in, I guess is the question. And so it says enter an interval notation using interval notation. Enter an interval using interval notation. Okay, so then I have from -5 with a square bracket, right, up to, but not in, and including -1, so that's another square bracket. Then for the next one, we don't include -1 because we've already defined the function to be -4 for that input. But there's a jump, so we jump up to 3, and we include, I'm sorry, jump up to 3, but that's between -1 and 2, right? All right, and then -1 if the input is greater than 2 or less than or equal to 4. Right? Now, I don't know, does it work if you hit the video? Do you get a, yeah.
Welcome to an example on how to determine the function rule for a piecewise defined function.
I don't know, is that helpful? Where are we? We're, oh gosh. Oh, what did I do? I've now scooted, oh, there we go, okay, we're here. So if I submit, yeah, that's what it wanted. So further questions about that? I'm glad you had a question. I love questions. We don't have access to this anymore. Please explain number 12. Oh, really? Is it closed now? I could open it back up if you want. So yeah, so here's, they want us to graph g of x equals -x squared minus 4x on the Cartesian plane. That's in honor of Rene Descartes. To graph this function, you'll first have to plot the vertex, the high-low point, then any other point. Okay, so we need to find the vertex of this thing, right? And for that, we need to do some pencil and paper work. So the function was g of x equals -x squared minus 4x. So there's two ways to go about finding the vertex of this. One is to complete the square in the honest way, which means factoring out the leading coefficient. The leading coefficient here is -1, right? So we need to factor that out. So we could say -1 times x squared plus 4x. Does that work? Or you could just write a dash, just a negative, right? You don't have to say that it's a -1. You can just put a negative, right? And if I distribute that -1, I get -x squared minus 4x, right? So that's correct. How about completing the square then? Well, inside the parentheses, we have a coefficient of 1, right? That's good. That's what we want. And an even factor. So we want to take half of 4 and square it, right? Well, that turns out to be 4, right? This trinomial is now a perfect square. But by adding 4 inside the parentheses, we've actually made this thing 4 smaller because everything inside the parentheses is negated, right? So what do we have to do to balance the equation? Add that 4 back in. So now these things are equal. For all x, these are the same values, right? Yeah. Don't have access to them anymore, huh? I suppose we should move on, but I could change the settings. You want access? Did I? Yeah. Oh yeah, 10:8. Oh, that was today, huh? Okay, how about 10:9? There we go. Did I? Okay, so we're back here. Oh, I wasn't showing you what I was doing. I was just changing the deadline to tomorrow. Okay, so you may have to reload the page if you. All right, so what do we have? We've completed the square. So now this trinomial is a square. What binomial? Oh, the scores got deleted? No way. Oh, yeah. There should be scores. I mean, at one point I deleted the scores, I think on Monday or something like that, when I had to like figure out a different way of setting deadlines because it just wasn't working. So I gave control over to my open math for that rather than Canvas, because Canvas just wasn't doing it. I don't know why. Seems to be inconsistent sometimes.
And one more thing, what I see, the every question it shows its answers.
Oh, uh-huh.
Yeah.
Oh,
So
so you've seen the preview?
yeah, answers, all the answers of each and every questions. So
Oh, okay.
I don't know, it's something
Is it at the
wrong.
bottom? Really? So you're getting the answers? Hmm.
Yeah, I see the show answer thing. I see in for
Oh,
every question.
let me go back over there and
Yeah,
look at
it's
that.
something related to setting, I think.
Um, yeah, thanks for pointing that out. So skip around. I think it's show scores on each question as it's submitted. Okay.
No,
Um,
before I submitted, I see this thing, the show answer thing for each and every question.
oh.
Yeah. Even I didn't start to do it.
Additional display options. Okay, let me show you what I'm looking at because it's not
Yeah.
polite to.
Okay.
Okay, so these are my settings, right? And 0 for unlimited reattempts, but you get a default penalty of 10% per missed. Can I change that to like a 5%? Oh, apparently not. Huh? Huh. Show answer. Okay, so show answers after due date. Right. So that's in the grade book. So that's because it was after the due date, but I have since changed the due date. So I guess you got into some loophole there, which is fine, right? Just, the idea is, use this as a learning opportunity. And, if you take it in the spirit in which it's meant, which I'm sure you do, then you're fine. So back over here, we were asking what binomial do you square to get this trinomial? Well, it's got to be x, right? So I need a new pen here. And what else can we say for sure? Well, it's got to be a plus, right? Because this is a plus. And that's got to be the square of whatever goes here, right? So that's got to be a 2. And does 2x plus 2 work? When you expand this, do you get 4x in the middle? Sure, 2x plus 2x is 4x. And 2 squared is also 4, right? So that's it's the number which twice the number is also the square of the number. That's the number 2. Okay, so so if you compare this with a times x minus h squared plus k, which is the generalized vertex form, we see that h must be -2 and k must be 4. So the vertex is at -2, 4. Looks like this one is also drying up. All my pens are dry. Okay, so the other way of doing this is, well, you look at A equals -1, B equals -4, and C equals 0 here, right? Because there is no constant term, right? So in general, you got AX squared plus BX plus C, right? And in this case, A is -1, B is -4, and C is 0. And so the formula for H is -B over 2A. So rather than going through the completing the square thing, you could just find H by plugging into this formula, which is -B is going to be +4, and twice A is -2, and that simplifies to -2, which is what we got for H, right? H is -2. And then K is G of H, right? And the name of our function is G. So I take that H value and plug it in. So that's going to be -2 squared minus 4 times -2. And this is -4 plus 8. And that's 4, right? Computing upwards for a change. Because that's where I have space. And so K is 4, right? So you know, take your value of H, plug it into the function. What comes out is your K. And that's consistent with what we got here, right? By completing the square. Okay, so that gives us what we want. And I'm going to go here and say, I've got my vertex. Oh, but we need another point, right? How about 0? Goes through the origin, right? If x is 0, then g of 0 is 0, right? 0 squared is 0, -0 is 0, -4 times 0. 0 minus 0 is 0. So it goes through -2, 4. So I choose the parabola tool, right? Because it is a parabola. We got some other kind of tools here, but we want the parabola tool. -2, 4. So that's the vertex. So you have to start with that. Then you can see, you know, depending on where you put the other point, you get different parabolas. So we want this one that goes through the origin. Okay, so where is it increasing? Well, on the interval from -infinity, there's the double 0 for infinity, right? Or double O, double lowercase o, up to 0. And generally, we don't say it's increasing at a point. So we'll say that's the open interval from -infinity to 0. And it's decreasing on the other interval, right? 0 out to infinity. It has, oh, I'm sorry, I got that wrong, didn't I? I forgot all about where the vertex is. So that's from 0 to -2. Okay. Okay. I was just looking at the chat. Apparently the problems disappeared and reappeared. Yeah, you have to reload them probably, right? Okay, so g of x has a maximum of, so the largest output is 4, and that's when x equals -2, right? G of x has a minimum. It doesn't have one, right? So it does not exist. Does not exist. The domain is all real numbers, which you can enter in interval notation like that, right? That's the interval from negative infinity to infinity, and there's your preview for that, right? And the range is the interval, that's the set of all outputs. So, you know, project this onto the y, all these points on the parabola, project them horizontally onto the y-axis, and you'll have the interval from negative infinity up to and including 4, right? Oh, wrong square bracket. And yeah, all of those are good then. All right. Any other questions? The scores got deleted. I think they won't be. Yeah. Gosh, I hope you don't have to redo them if you've already done them. That would be wrong. All I did was extend the deadline, right? So that shouldn't change your scores. I could go in and look at that if you like. So this is what we want, the grade book. And this is I don't know which one is it. Functions, homework 1. Okay. Yeah. Looks like they're still there, right? So your old scores are still there. And it says in progress now for some of them. Okay. Sorry to show everybody your scores. That's probably not politic, right? All right, so let's go back. Can we go back all the way back to, well, I think, can we just, sorry, let's go to modules and pick up transformations. Unless you have some other questions. Oh, Kelly says did you try reloading? Kelly Meyer. Oh, you're not in here. Oh, that's odd, huh? So it's probably, if you were in the, how is this possible?
Yes, it also shows 0 for mine because I told you
Yeah,
the problem shows the answer. It means it says that you means you already crossed the deadline. So I think that's why it shows the 0 means 0 score.
well, that's wrong, isn't it?
Mhm.
What if we go here? So the problem is that there's 2 grade books, right? There's the one in Canvas, and then there's the one in My Open Math. And let's see, can I scroll over here to, all right. It's not even here. Um, 4. Yeah, I don't even see it here as a thing. Oh, because it's not due yet, maybe? Yeah. So it could be. So we'll see tomorrow, maybe, whether, let's see. So Kelly, are you even over here? Kelly Meyer. I need to scroll up here. Yeah, you are here. All right. And again, I'm sorry for displaying all these things, but yeah, I haven't graded the tests yet. But well, what I'll have to do is just manually enter what I see. But how come I don't see you in? Yeah, there's no Meyer over here. How is that possible? Uh, Strange. Okay. I'll have to figure this out on my own time because I don't want to take up your time figuring it out. Because there's one thing after another with this My Open Math Canvas integration that's not very well done. Um, maybe it's user trouble, but I tend to think it should work better. I mean, I had to change some settings and maybe that, but I think, yeah, there's, when you enroll in Canvas, you should be automatically enrolled in My Open Math because it's integrated. But it appears that some of you also enrolled in My Open Math separately. Is that what's going on? And then didn't enroll, or if you only enrolled in Canvas?
Do we have to enroll in both? Because I'm not enrolled in I mean, I don't really go on the My Open Math website.
Yeah, I mean, you
I
get
just
there
go through Canvas.
Yeah, and that should be fine. It should be fully integrated.
Yeah,
So
but
I
sometimes
will,
when I go on the My Open Math website, it shows a different score. Like it shows a different grade
yeah,
in the grade book.
I know. I've seen that too, and I've tried to fix it, but apparently I need to do some more fixing. So let's not fuss over that now, and let's just say, there's forgiveness if there's error on my side, of course, right? So yeah, I guess what we'll do is go here, here, and let's take up where we left off in transformations. Which I think we on question 3? Yeah, we did question 3. Yeah, so notice that it is parameterized. This time it's a +5. And so, yeah, you are seeing the horizontal asymptote at 5 here now, right? Okay. Question 4, draw the graph of this function. Okay, so so what is the base function here? It's a square root function, right? What are the transformations? Well, there's actually 3 transformations. Let's write them out. So pencil and paper. Um, so so our function is f of x is square root of 3 minus x plus 4. Okay, so we're going to start out with, so the base function is y equals the square root of x. And we know what that looks like, right? That's the upper half of a horizontal parabola, right, which goes through the point 1, 1 and 0, 0. Okay, I've got 4 dry pins now. Okay. So now what should we do first? I'd say there's 3 transformations. There's a horizontal shift. There's a reflection across the y-axis. Should we do that one first? It does matter what order you do them in, although there are different ways of getting the same result. So if we were to first reflect across the y-axis, then we replace x by negative x, right? So we get y equals the square root of negative x. And what does the graph of that look like? Well, it's a reflection in the y-axis. So we still go through 0, 0. That point stays where it was, right? Reflecting across the y-axis. But the point 1, 1 here gets reflected across to negative 1, 1. And this is the y. I should be labeling my axes, right? All right, so now if I plug in negative 1 for x, I'd negate that. That's the first thing I do. I just negate negative 1, and that's a double negative, which gives you a positive 1. And the positive square root of positive 1 is positive 1, right? And so input negative 1 leads to output 1. Alrighty. So now how do I get the 3 in there? I need to replace x by something. Should I replace x by x minus 3 or x plus 3? Well, remember, when you replace x, you need to do to x whatever is being done, right? So we're going to negate the whatever I replace x by, right? And if I want to end up with a positive 3 and I've got a negative here, I should replace x by x minus 3. And then I will have y equals this positive square root of the negation of, in parentheses, x minus 3. And that's going to shift 3 right. I didn't say what this does. This reflects across the y-axis, right? Let's reflect an F. So it looks like reflect or something. Reflect. Okay, so and notice that when we distribute the negative here, what do we get? Well, I guess we could write it as negative x plus 3, but that's the same as 3 minus x, which is what we want, right? That's what we got, right? So and then the plus 4 will just shift up 4. But let's first graph. So we're shifting 3 right? So this point at the origin is now shifted 3 right, and this point at negative 1, 1 is shifted 3 right to 2, 1. Right, so our parabola, the upper half of our parabola now looks like that, right? So this point, negative 1, 1, we shifted 3 right, and this point, 0, 0, we shifted 3 right, and then we got these 2 points, and that's the way it looks now. And then we replace y by y minus 4, that's a shift up 4. So you get y minus 4 equals the positive square root of 3 minus x, and then add 4 to both sides. So you've got y equals positive square root of 3 minus x plus 4. And if I can graph that, I'll try to graph that. So this point 3, 0 went up here to 3, 4. Right, the y coordinate increased by 4, and this point 2, 1 went up here to 2, 5. And the parabola now looks like this, right? The upper half of the parabola. That's rough and ready. I suppose we could look at this in GeoGebra as well. Let's do that. So there's a comment here from Maria. What if x, I can't quite tell. Okay, that's a private. Kelly is saying he's going to redo his. Well, it doesn't hurt, especially if you've done it once. It won't take you long to do it again. Sorry about that. Yeah. So, yeah. So let's just review all this, right? Since there seems to be some confusion. So this is where we want to get to, and this is the function type that we want to transform into this, right? So our basic function type is simply positive square root of x. So to get a negative x under the radical, we just replace x by negative x, right? There is another way to go here, but maybe we should talk about that. But if we were to first do the reflection, then replace x by negative x, you get positive square root of negative x, and that reflects across the y-axis, right? Then if we replace x by x minus 3, so I see Maria is suggesting that her parameter is 5. Yeah, so yeah, you'll have to adjust this for yours, right? On mine, just to be sure, I'm looking at this function, right, which is positive square root of 3 take away x, and then add 4 to that square root. Right, so you may have different parameters there. But so let's go ahead with the GeoGebra, and I will delete these guys and put in square root of x. That's our basic function type, and notice that it goes through, you know, it's good to have some anchor points. So in fact, the vertex of that parabola is at 0, 0. It's a horizontal parabola, and you don't see the bottom half of it, but it's, you know, the formula for the bottom half would be the negative square root of x, right? And that would give you reflection across the x-axis. But we don't have that part. Our outputs are all positive. So then if we do square root of negative x, that reflects it across the y. Oh, so I wanted to plot a couple of points. So 1, 1 on the original curve gets transformed. 1, 1. Didn't plot that point. Oh, it's just turned off for some reason. Oh, it thinks it's a. It thinks it's a slider. Why do we have a slider? I don't want a slider. Delete. Okay. Let's try that again. 1, 1. There it is. Okay. And that gets reflected to negative 1, 1. And so then if we replace x by x minus 3, then we get the square root of the negation of x minus 3, which is the same as the square root of 3 minus x, right? And there you see that shift to the right. And so the point that was at 0, 0 is now at 3, 0. And the point that was at negative 1, 1 is now at 2, 1. And so on, right? That's a horizontal shift. And then we want to shift upwards, right? So I can say square root of 3 minus x plus 4. And so the point that was at 3, 0 is now at 3, 4. Point that
Just the bagels from Starbucks.
I'm sorry? I think maybe that was not intentional.
Just the bagels from Starbucks. That's all I was gonna say.
Okay, yeah. So somebody is not muted.
Bomb.
Yeah,
Those are good. They have like a nice like felt.
somebody's not paying full attention.
I do.
So two,
I do. They're not nasty. You don't know nasty. What else is nasty? Like what else?
okay. Sorry, Xavier, I had to mute you. You were babbling about something. I don't usually do that, but it was an occasion. All right, so okay, I'm here, right? So the point E, which was at 2, 1, now gets shifted up by 4 to 2, 5, right? So I'm just, following a couple of anchor points through these transformations. So what's the whole story for this point B? It gets reflected to C, it gets shifted to E, and then it gets shifted right 3 to E, right? And then it gets shifted up 4 to G. Right? And there's our new curve, right? So when they want us to graph this, we need the graphing tool, and they've already given us the graphing tool. And the way you graph it is by first plotting the vertex point and then one other point. And I've got those here, right? So 3, 4 is the vertex, and 2, 5 is one other point. And it likes it. I got the green check. so we're all good, right? I said there was another way to do this. You can do the shift and then the reflection. I did the reflection and then the horizontal shift, right? What if we were to do the shift and then the reflection? Is that possible? Yeah, but it's going to be the opposite shift. Let's see if that doesn't work. Yeah, I'm going to say shift to the left first. So I'm going to repeat the function is square root of 3 minus x plus 4. And we start out with our base function, which is just the square root of x, right? So now if I first shift to the right, I'm sorry, to the left, right? Yeah. So we reflected and then we shifted to the right. If we first shift to the left and then reflect, I think that'll work, right? So shift left 3, right? And that's accomplished by replacing x by x plus 3. All right, so then you get y equals the positive square root of x plus 3. And what is the graph like? So this graph is, you know, like that, just roughly speaking. And then this graph is going to be, you know, the vertex gets shifted 3 to the left. Yeah. And so does every other point get shifted 3 to the left, right? Is that visible? Okay. And then reflect. So reflect across y-axis. And that's accomplished by replacing x by negative x. So everywhere we see x, we write negative x instead, right? And so so you get y equals positive square root of negative x plus 3, which is the same as positive square root of 3 minus x, right? Okay, so all points get reflected across the y-axis. So up here, this point would go to positive 3. This point would go to here. The point on the y-axis doesn't move, right? So the new curve will look like that, right? Well, it should go through this same y-intercept, right? And then shift up 4, right? So but yeah, so with reflection, it matters which one you do first, whether you do the shifting or the reflecting. And it's a different shift if you reflect first than if you reflect second. All right, that's kind of a subtle point, so I wanted to make it. Should we look at that in GeoGebra? So let's turn all these guys off and turn all these points off. Okay, actually I want this point and this point, right? So I first shift to the left, to the left, yeah. So that's f of x plus 3. And then I have q, I want q of negative x, right? So q of negative x will then reflect across the y-axis, and then I can shift up, right? And I'll end up with the same thing I had before, but you know, through a different process. So there's not a unique sequence of transformations that will give you that, depending on which horizontal transformations you do in which order. All right. Yeah, I did mute him, which is too bad because now you can't. I hope he doesn't have a question. Okay, so let's let's go to here and look at another one. These are good fun. The transformation of a function f into a function g is given by, oh my goodness, look at all that. So what's happened? Oh, well, we have a horizontal shift, we have a vertical shift, we have a horizontal compression or expansion, and a vertical compression or expansion. So A vertically scales the function. So that's a vertical compression or expansion. And actually, if A is negative, then you also have a reflection about the x-axis, right? B horizontally scales the function. A negative B reflects the function about the y-axis. Yep. And H is a horizontal shift. Well, it causes a horizontal shift. It sort of depends on whether, did you compress horizontally first and then shift, or did you shift and then compress? So this looks like if you first shift left by H, then compress by a factor of B, then you'll get this, right? And then K is a vertical shift. And again, if you do the shift first and then the compression or expansion vertically, that's what you'll get, right? Transform f of x into g of x, where the transformation is g of x. Well, okay, so what do you got here? A is 1, and B is 1, and H is 0, and K is 3. So that's just a shift up 3, right? Okay, so we get this point and that point. Oh, and we draw the line segment connecting them. Right, so that's just a shift up 3. Oh, that was easy, despite all the complexity of the background. 6. Again, we have all this complex background, but the actual transformation is a horizontal shift. Which way? How far which way? Oh, you can't see that. We got x plus 1. So that's actually a shift. So it's like you're replacing x by x minus negative 1. So you got a shift to the left of 1. All right, so I'm going to take, well, I suppose the dots first, and then the line segment. Yeah, that's what they wanted there. Are there more of these? Yep, there's another one. Here we're going down 1, right? Okay, how about here? We're going right 3. These are quick and easy, actually, it turns out, right? Here we've got a more complicated thing going on. We need to sort of scroll over there. Draw the graph of this function below. So this is a shift 3 to the left. And they suggest that, you know, to finish drawing, you need to click outside of the graph. Okay, so 3 to the left, huh? So we're drawing a polygon, okay. And if we were at -4 and we're shifting 3 to the left, then we're going to be at -7. If we were at -3, 3, then we're going to be at -6, 3, right? And then if this point was at 3, -1, then we're going to be at 0, -1. And they say click outside to stop graphing. Does that look reasonable? It's the same shape shifted over 3 to the left. And in order to see my submit button, yep, it's happy with that. Oh, we're after time. We're a minute over. Okay. Well, so what happens at the end? Okay, so it's just more of these things, right? Yeah, so you get to practice, you know, your transformations here. And I guess that's what we did today, was just practice transformation. We did a couple of the old ones, and we fretted about the homework, which I'll have to fix somehow. But this is the end of week 6. I will bid you a happy holiday weekend. It's not a holiday. Every
Also,
weekend is a
I
holiday.
have a few questions.
Yeah, go.
The first being about the homework of the functions homework 1 and 2,
Yeah.
both under I'm not sure what they're under, but they're not under homework. Or
Oh, is that
they're
right?
not, yeah, they're not under the grades area when I go to double check.
Yeah, yeah, I noticed that too. I'm gonna have to fix that. Like I said, I'm gonna do that on my time because it's kind of embarrassing to have to like show what I don't know about Canvas. I don't care to know it, honestly, but I guess it's my responsibility. So I gotta figure it out. It seems like it should be a lot more straightforward, but maybe it is. I'm just an idiot.
Thank you, Professor. And then also the class recordings from yesterday and today,
Are they not up there yet?
they're not.
Oh, okay. So, well, here's 10.5 and 10. Oh, yeah. So yesterday was 10.7.
Yes.
Yeah, let me get that right out of the way. I can
Thank
do
you.
that now. While we're speaking, if I can find my email box, that's where it's going to be. And I've got so many tabs open here, I can't find. Oh, yeah, I'm there. Okay, so this would have been on Wednesday at about Zoom. So this is for Math 5, but that's the first. So I get 2 of these, right? And the second one has the annotation. So that's the cloud recording. Audio transcript, but that's for the morning one. Looks like they didn't give me a transcript for yeah, unless I'm just not seeing it. Okay, well, I'll just put up the one without the transcript.
Okay, thank you. And then I also wanted to make sure I was counted here today for attendance. I was a little late.
Oh, what's your name? I'm sorry, we're not looking at the gallery. Sorry. Say again?
Jadzia.
Oh, yeah, okay, yeah.
Thank you.
Professor,
Okay,
could you
yeah.
also mark me here? I came in a little late as well. My
Okay,
apologies.
so I have to do this, but just give me a second here. Class video. So I don't have today's yet. It takes them a while to process it. But this was 10.7. And there we go. Publish. And so if I go over to here, Jadzia, yeah, Jadzia. And I'm sorry, who was the gentleman who was speaking?
Blake and Travaya.
Oh, Blake, okay. Yep. Okay, done. All righty. Any more questions about anything? Yesterday came in a little after attendance. Let me take a look at that. Yeah, okay, I'll mark you present. That was a private message, if you're wondering. Yeah. Okay. You need some help with some of the homework? I'll be in my office between 10 and 11 tomorrow. Is that a good time? Okay, great. So yeah, I think you can reserve that now. Is it clear how to do that? I have the how-to guide here somewhere. How to use office hours, right? It's back here. And I forget which module that's in, week 2 or something. Yeah, that's in week 4. Circles, oh my. And this is the end of week 6. So I will bid you a pleasant weekend. And
Professor, quick question. What do you
yeah.
want us to read over the weekend, just so?
Yeah, in the text, and let me bring up the text, which is not quite visible because it's too small. How do I fix that? Here, and get rid of this maybe. Zoom in on that. So yeah, there's all this. So all this section on shifting and stretching and reflecting, right? And I think that's pretty powerful stuff. If you can get a handle on that, you really, get to control your understanding of a lot of far-flung different kinds of functions that fit into the same categories, right? But then if you could read ahead through the section on the next 2 sections, if you could read ahead through those, that would be really helpful, because then you will have had one go through, and then we'll go through it again and make sure that so the 2 sections there are oh gosh, yeah, 2.8 one-to-one functions and their inverses. This is going to be important for trigonometry. The previous section is now if I can get to it. What is it again? It's scrolling it. Combining. So yeah, sum difference products and quotients of functions, but in particular the composition of functions, which is going to be sort of pivotal for doing inverse functions and applications of composition. So yeah, so we'll want to have a good grasp of sections 7 and 8. 6, 7, and 8 are kind of the essence of this chapter 2. So if you can get those down, you'll be in good shape. Yeah, good question. Reading ahead is a good idea. And we're going to be finishing up chapter 2 early next week, the first couple of days anyway. And then we'll start in on the trigonometry proper.